Welcome, everyone. My name is Kathy Alger. I'm the Executive Director for Crew DC. Thank you for joining us today for this session. And what I want to start with is by saying thank you to our sponsors who you see here on the screen. Without this corporate sponsorship, Crew DC and Crew Network really couldn't do its work for the real estate industry and for our members and for our stakeholders. So we thank all of our sponsors for their ongoing support. I want to make sure that you all know about the Zoom etiquette, which is that you should keep yourself on mute unless you're speaking. We are going to have question pauses during the presentation. You can submit your questions through the chat. We are going to be monitoring the chat and organizing that for the question pauses. You can also speak up, but we are going to have 80 or so people on the call today, so it might be a little bit difficult if everybody tries to speak up at once. So I strongly recommend the chat. And so without further ado, I'm going to turn it over to Lauren Luckett from Paladino Associates, and she is going to kick it off and introduce us all to our speaker.
Thank you, Kathy. Hello, everybody. My name is Lauren Luckett. I'm the Client Development Manager at Paladino and Company. Before we kick off our presentation, I just want to briefly introduce you guys to Paladino, tell you how we think and a little bit more about how we do what we do. So Paladino is a green building consulting firm. We have two offices, one in Seattle and one in the DC area. And we link sustainable strategies to our clients' values and goals. And we really use sustainability as a business driver for them. We believe sustainability, resilience, wellness, they can all improve both market traction, address climate issues, and also build resilience into properties and businesses. We work with owners and operators from all different verticals within the commercial real estate industry. And we're also considered one of the pioneers of the green building movement, mainly because we help develop LEED, but we focus and continue to focus on the future of sustainable real estate. One of those focuses is carbon. And I'm going to hand it over to Tom Paladino, who is the CEO and founder of Paladino and Company, and he's going to take us through the presentation. All right, take it away, Tom.
Thank you, Lauren. Good morning, everybody. We don't have any hand signals that I can see, but I hope you're all doing well, staying safe, staying focused, trying to find joy in the world. That's our mantra at Paladino. I thought today I would share some thinking at the firm as we've all been adjusting to our new work style, lifestyle, and this pandemic experience. And it's been a real mixed blessing for a lot of us. I find myself with a lot more free time. I'm also working more than I ever have, and I'm kind of perplexed by the situation in many ways. I see these images like the canals in Venice are now clear because there's no traffic, no tourism, and no commerce. So fish are coming back. Air quality across Europe has gotten better because of the pandemic, simply because of the massive shutdown in commercial activity. So there's great damage to the economy and to people's jobs and their lives, and yet at the same time, the air is cleaner than it's ever been. There's no trash in Yosemite. You can see El Capitan. Nature is back in the park, on the roads. There's no encroachment by people. And it's a global phenomenon. The impact of human activity in commerce is really apparent when it instantly disappears. And I find myself, wishing there had been a better way to find a way through climate change and pollution and the human impact on wellness from all of these sort of negatives of our commerce. And yet here it is. And one of my mentors has taught me over the years to never waste a crisis. And so I've been thinking a lot about what's happening to us now, and is there something to learn around climate change. And so, you know, the challenge with the COVID-19 virus and the disease and the pandemic is that it's an invisible exponential problem. And the challenge of a problem like that is it's really abstract and unrelatable. It's too big to tackle alone. And there's really not an obvious place to start. So does anyone want to venture a guess, maybe in the chat window? What are these graphs? Anyone have a thought? I don't know, Lauren, are you getting any chats?
Nope, I'm not seeing anything.
Okay. Well, the chart on the left is the pandemic that we're all in right now, and the time frame is 20 days. It's an exponential, invisible problem that has totally turned our world upside down. The other graph are greenhouse gas releases. It's the same curve. It just has a longer time frame. It's an invisible exponential problem. And we've been working on it for a long time. I've spent most of my career trying to create impact on reduction of climate change and greenhouse gases to our planet. It's something I'm passionate about, I care about. I've built a company around that idea. And so I thought, we've got these two problems. They're similar in that they're invisible and exponential, and they're difficult to solve. Clearly, we haven't solved climate change. And yet, we are flattening the curve in the COVID pandemic. And this idea that Thomas Pucioio has put forth around how to flatten that curve is, the first thing you do is hit that curve with a hammer, and you just beat it into submission, or suppression, I think is what the immunologists call it. And then you have this dance where once you've got it beaten into submission or suppression, you have to deal with it on an ongoing basis. And I look at some of the curves around air quality and traffic, those curves have been beaten down with a hammer. They have been flattened. And so I wonder, what is it we could learn from our experience right now as we reflect on going forward and what our lives are going to be like sometime in the future? And how can we, as commercial real estate professionals, learn something from this sort of horrible time that we're all in? And so as I thought about what's happening out in the world that I can relate to, I asked myself three questions, and here they are. What is the one thing I should start doing? What is the one thing I should stop doing? And what is the one thing to fight for in every project? Because that's how I hear the health system and experts and leaders in the health industry are talking, and so I'm following their lead more than anything, with a sense of maybe this experiment that we're all in can provide us some learning and moments of leadership in a new way. So I spent some time living in New York City and visited the Javits Center often. Mostly I was looking at, you know, vendor booths or dogs in dog shows or cars at car shows. And these were the images that were starting to come across my screen of many hundreds of hospital beds for victims of the COVID-19 virus. And it really hit me that what was so startling about this was this invisible challenge suddenly became visible just by looking at these beds and these images. And I realized, you know, there's a clue there in terms of once you make the problem visible, you can begin to attack it. So I'm going to show you some insights where we've learned how to make the invisible visible, working with teams in our DC market, Department of State, Amazon, EYP, Hickok Cole Studios. We've worked with the teams from this DC market where we've learned how to make the invisible visible, and we didn't even realize we were doing it at the time. And then out of our Seattle office, we've got some lessons from working with Expedia, and Ectope, and NBI embedded in this work. So I just wanted to thank all the leaders that I've worked with that have helped me understand how to make the invisible visible. So greenhouse gas and global warming potential are invisible and hard to understand for many of us. There's this protocol called the greenhouse gas protocol where it buckets emissions into 3 classifications. Scope 1 is direct emissions from something you control, like you buy gas and you burn it on site in a boiler. Scope 2 are emissions from purchasing energy. So that's, going to Dominion in DC and setting up your new account to turn on your lights. And then Scope 3 is any other direct, indirect emissions that occur in some value chain related to your enterprise, like buying concrete and erecting a building or sending a van to deliver a package to a consumer. Those are all Scope 3. So it's handy, it's 3, so it's simple, but it's still not that relatable. So one of the insights we've had is to make the invisible visible by simply making it also relatable. So this is a diagram of a project for a client interested in carbon and climate change. And all we've done is draw the scope 1, 2, and 3 to make it visible. So on the left, we have renewable energy that you can buy from an offsite array. You can buy carbon offset purchases from third parties offsite. So that's where, say, methane from a landfill is extracted and recovered. On site, you can do ground source heat pumps. You can reduce the carbon in your concrete. You can put PV on your roof. Those are all on-site strategies for reducing carbon emissions. You can change your boiler from one fuel to another. Many of us don't realize that refrigerants have one of the worst global warming potential factors out there. And so when you have a rooftop air conditioning unit, it has refrigerants in it and they leak. And so replacing them every year is a carbon emission. And then we've got our utility from the local provider. Sometimes it's pretty dirty power. Maybe it's coal-based, which is the dirtiest power out there. Maybe it's natural gas, which is a lot cleaner. Maybe it's from wind, and that's the blue power line. And then often companies have transportation emissions from their internal combustion engines or ICE in their vans or in their fleet of vehicles. So first step to make the invisible visible is to make it relatable and just get the picture drawn. So we found that to be a great first step. And then make one next leap from the picture, which is to just put it into a grid, which could be eventually turned into Excel so you can track the math. So row 1, my direct emissions. Row 2, my indirect emissions. Row 3, they're indirect and they're not mine. And then write down where you have emissions or carbon flows on your project and just do a quick tally and make that invisible visible. So I'll pause there and see if there are any chats. Lauren, any questions? Okay, feel free to chat. So here's another way we've been making the invisible visible. So the way to read the graph is on the right. The blue and the red bars are electricity, EUI, and combustion, EUI. Those are the stack columns. The two curvy lines are heating degree days. So you can see the heating degree days, the red line is highest in the winter and lowest in the summer. And the blue line is highest in the summer. That's a cooling degree day and lowest in the winter. So that's weather plotted against energy use. The left-hand graph is converting the energy use to the carbon footprint. So the black graphs are electricity, And then the orange, blue, and gray are the carbon emissions associated with natural gas and leakage in the supply system. So when natural gas leaks out of its pipe on its way to your boiler, it enters the atmosphere as a fully uncombusted chemical, which has much greater global warming potential than simply oxidizing it. So there's a leveraging effect of gas that escapes from a pipe. And so that's the first aha, is that, well, it looks like maybe gas doesn't contribute very much. If you account for its global warming potential, it's actually quite impactful. So this is a ground up new hotel in DC. It's from an energy simulation required by LEED or by Arlington's 4.1 process. I don't know the exact location, but it's one of those two. We're driving it. In the upper right-hand corner, you can see this hotel has an EUI of 62. So the other visualization is that big negative 13. That's if we put PV on the roof of that hotel, how much we would drive the EUI down of that building. Almost 25% just through roof-mounted PV. And then over on the left side, you can see operational carbon of about 2,000 metric tons per year. So now I'm going to advance to another building in Washington, D.C., an office, a larger building, almost twice the size, much more efficient per square foot, the EUI of 32, and the carbon is almost equivalent. So thinking about buildings being large and energy inefficient isn't sufficient any longer. You really need to understand the energy use intensity and the carbon contribution. So we have an office building twice the size of the hotel. The hotel has a lot of high energy intensity around hot water and heating. The carbon footprint's actually equivalent. And we wouldn't know that unless we were visualizing the invisible. Now, these are both in the same grid, the RFCE energy grid in the US. There are 14 grids in the US. And if you make the invisible visible on grid factors, here's the way we begin to show carbon in our office. We're using this tree plot function in Excel, which helps you visualize these really hard to keep in your brain numbers. So the upper left-hand corner is the MROE grid, which has the highest carbon per kWh in the country. In Washington, we're using the RFCE grid, that lower right-hand corner yellow box above the dark green box. And it has a carbon grid factor of more than half of the other grid. So thinking about climate change is not just about getting the energy levels in your building down. It's about thinking about, I'm trying to reduce the carbon, not necessarily the energy. And so here are two more simulations in the DC market. Actually, it's one in the DC market, a multifamily building, 300,000 square feet with an EUI of 41. And it's in that RFCE grid. And you can see it has an operational carbon footprint of somewhere around 3,400 metric tons, depending on which global warming potential for the leakage of the gas. And then if I just pick this multifamily up and moved it to Missouri, same project, same EUI, but because of the grid, the carbon footprint is over double. And so if you're a developer like Brookfield, who's got a national portfolio trying to bring their carbon footprint down, and you have a pattern book for multifamily, it's not as simple to improve the lighting of the multifamily or the heating of the multifamily in one location and think you have it licked, because depending on the grid you're in, you may be solving the wrong problem. So make that invisible visible by beginning to focus on the carbon, not just. So I'll pause there. We have a question.
We have one question. They want to know, confirm that embedded carbon is included in the calculations and it's not just operational.
Good question. The grids I'm showing you right now are operational. So I haven't gotten to embodied, but I will get to that. So this is the first visible and invisible. And I'll touch on carbon next. So thanks for that question. So this is an image of a person working in a factory near where I am right now in Seattle. I have a professional colleague who runs a company called Cast Tailored, and they make upholstery for the airline industry. So Boeing's been having challenges. Their companies had some challenges with the environment anyways, and then COVID came along, and they have over that were on the verge of all being furloughed. And they heard about a hospital system here in the Seattle area that couldn't get any masks. And they realized, hey, we sew fabric. Masks are made of fabric. We have 200 people who have no upholstered seats to make for airplanes, but we have fabric and we have people. So they set up a prototype. Here's one of the designers creating this mask prototype. And within a week, they had 27,000 masks. And within the second week, they were at 100,000 masks a day. And so the resilience of business to tackle an invisible exponential problem, I think, is all around us. We just have to look for it. There was a nearby company, Bad Dog Distillery, closed down here in Washington State due to the social distancing. They pivoted, turned their distillery output into creating hand sanitizer and contributed to the solution. And I think the lesson I learned from watching my colleague is that he really made the impossible possible. 100,000 masks a day from a place that really wasn't built for that. And so we've been fortunate to work with some teams in DC, making the impossible look possible, at least providing a path. So I just want to thank ZGF, GHT, Clark, Thornton Tomasetti, and JBG Smith for some of the work that we've done together that I'm going to share. And also some of the pressure and encouragement from Seneca, Amazon, and Skanska in Seattle. You've all helped us at Paladino understand you can make the impossible possible. And so one way to make the impossible possible is just you've got to learn how to break down the problem. And so as we are working on a path to net zero with one of our clients, we realized there's really 3 work streams that need to get on this all at the same time. And they won't be able to progress at the same pace, nor do we want them to, because if someone gets ahead, we don't want to slow them down. And if something's going to take longer, we don't want another group to cut corners. So we broke the carbon problem down on this particular project by separating out what can procurement do, who's buying carbon. And so back to the question from the audience, does this include embodied carbon? Often procurement drives embodied carbon. And so think about procurement as a property manager. You're buying refrigerants, maybe you're buying fuel oil for generators, but it can also be procurement in that I'm releasing an RFQ or a bid package as a contractor to 3 concrete trades or three subs in the concrete trade, and I need to tell them what I want. And that doesn't have to proceed at the same speed as the design of the structure. So learning how to break the problem down is key. And that's what I learned from Cast Tailored and Bad Dog Distillery, is that if you break it down, you can shift and pivot faster. So back to our grid that we filled out earlier, my direct emissions, my indirect emissions, and indirect, not mine. And then all those carbon flows that I mapped out for you on the picture. So the only difference between this grid and the last grid is that I've identified the who. So my direct offsite carbon purchase, it's the property manager who's going to make a carbon market purchase based on design. So I'm going to go off to Dominion and I'm going to tell them, I think my EUI based on my model is 42, which is step 1, make the invisible visible. I want to buy all renewable power. What do I need to do? So property manager knows their first step. Another example would be, I want to put on-site on top of my project, that hotel where I could take 13 out of the 62 EUI down. I need to procure roof-mounted PV. Well, who are the providers? What's the cost? Am I going to lease it? Am I going to buy it? So procurement, PRO, has their list of to-dos. And then you simply tally up property management. I'm going to go out, I'm going to buy that purchase. I need to figure out how I'm going to manage EV charging in the garage when I have 300 stalls and 20 chargers and 60 cars. Like, I need to know how to do that. So I need to call my colleagues and look for other people that have figured out how to break it down. And then I have life safety generators. Can I get them fueled with biodiesel? Who sells biodiesel? So the property manager has a discrete piece of the puzzle that can operate at a disconnected speed from design and construction and from procurement, and vice versa. So break it down, assign accountability, and make sure you have the what by whens, who's doing what and by when. So it's really simple process, and that's how you make 100,000 masks a day. So another challenge we've been hearing about is testing, testing, testing. If we could only test. And I've been thinking, this is sort of astonishing that we can't test, but it turns out testing requires a chain of people to do things exactly in a consistent way. You need the PPE, and you need the tester, and you need the swabs, and you need the vials, and you need the lab to do the test, and then you have to get back to the person and tell them what they need to do. And so breaking down that problem is another way of thinking about carbon. So imagine you're on a design project and you have a client that's interested in low carbon, zero carbon. And there's a question around, well, we have to certify, do we want to tackle the LEED LCA materials credit? It requires you to look at CO2e, or carbon dioxide equivalent, and collect environmental product declarations. If we're going after the ILFI embodied carbon certification, we have to hit a target of 500 kilograms of CO2e per square meter and reduce against our baseline. And if you're thinking about making a recommendation to a smart client that demands good knowledge when they're asked to make a decision, we realized we didn't have enough information to even present this as a go, no go to the client. So we had to go back and start over with a 3-step approach. So this is breaking down the problem. And so we looked at some of the standards. The embodied carbon of projects generally is driven by 3 primary assemblies: foundation, structure, and enclosure. There are a lot of parts in those assemblies. And this is another type of diagram that makes the invisible visible. This is a Sankey diagram of carbon of embodied materials in a building. And it's terrifically complex and sort of beautiful in a way, but what do you do with it? And what we realized is that there were a handful of materials that actually drove the answer. And so we realized that we did not need to solve all parts of that complex chain like I described in the testing, is we really needed to focus on 3. And so we created this process with the architect, the engineer, the contractor, and Paladino as the consultant. Really all we were was the quarterback. All the content was generated by others. And the first thing we did was, well, we need the quantities. And we realized that we should just focus on the 80% of the answer, which was concrete and steel. And we suspected carpet. The structural models turned out to be too complex to use, so we did hand takeoffs, cycled it through the embodied carbon of construction calculator, saw that we were on the right track, and then we worked with procurement through the contractor to see if we could get some traction with the concrete producers in the DC area. And so we broke the problem down into 3 work streams, and we assigned one person in charge of each work stream, and then we convened as a working group over about a 6-week period. So we broke it down, and then we assigned accountability for a part of the problem to a person, to a name, not a company, and then marched it through on the what by when to find the answer, which was focus on 3 materials, not the spaghetti that I showed in the Sankey diagram. So I've talked about making the visible, making the invisible visible. And once it's visible and you realize how complex it is, you really need to make that impossible task possible through work breakdown and accountability. And then as you stand back, you have to think, well, where do I focus? Like, what is my hammer as I try to bend this curve? And as an individual leader, how do I focus, and what should I focus on? And I'm just living the life you all are here in Seattle. I'm wearing a mask during the day. I'm maintaining social distance. Social distancing was the hammer that helped drive the curve down. And so I wonder about what is the hammer for us on climate change? And as a leader, what should I advocate for the next time I'm asked, how can you help with the climate problem? So I realized the question I'm really asking is there one thing to fight for on a project? What is the hammer I have that's available to me as a professional? And so if you think about what we're trying to do with carbon, we're trying to basically eliminate it from the project in a rational way. So here's our old friends, scope 1, scope 2, scope 3, arranged in a stack diagram, stack column. Scope 1 is usually a relatively small fraction of the total carbon footprint. Scope, I've got the labels wrong. I'm looking at it. I realize I have them wrong. Scope 3 is the dark orange box. It's a lot bigger than scope 1, but it's often not as big as the emissions of scope 3. So the first step is, how do I drive down scope 1, which is from combustion and release of refrigerants? If I can drive that out once by simply not bringing that system into the project, I've eliminated that emissions from my total. The second step would be, how do I reduce the embodied carbon, the dark orange box, and the running emissions from buying purchased utility electricity, which is the big middle orange colored box, and get those down? I can buy an offset on the market, natural system offset, so forest preservation, grassland preservation. I could buy an offset for a methane recovery plant, a landfill cap plant, and eliminate or neutralize the carbon from embodied construction, which leaves my running carbon. And the challenge with running carbon is it happens every year. So this scope 2 body carbon goes out to the right forever. That's the whole problem with the exponential invisible problem, is every year there's a new set of emissions. So if I can solve that block, that's my hammer, because that's the one that has the longest impact on the tail. So I've been thinking about my hammer, and then I've been researching that weather impact I showed you at the beginning of the presentation, from the drastic reduction in commerce and travel and miles driven. And I'm reading in the press about the price of renewables continues to drop. And I realized I'm kind of looking at a invisible exponential solution. It's right in front of me that curve is just tipped on its side, but the cost of PV is getting so low, and the cost of wind and concentrated solar power are also dropping, as you can see in the curves. There's a different exponential issue happening out in the market, and we're finding that when you do the math on renewable energy, there's two almost freebies. One is that when you lock into a long-term power purchase agreement, you guarantee no rise in your electric costs because you're basically buying the plant, a small plant, a 5-megawatt plant, when you buy a PV farm ownership. And so it provides stability. It's not just about being good for the environment and removing carbon. It provides stability for your business, and it's become so cheap. It's become the go-to capacity for utility companies to add to their portfolio. So just yesterday, I read in the New York Times that this year, first time in history in the United States, we're going to produce more electricity from renewable power than coal. First time ever this year. And that's amazing. More from renewable than from coal, which is the dirtiest power source. Now, will that create some economic hardship? Likely, but we're all in economic hardship right now. And it's not so much about the jobs, it's how much carbon do we emit from our way of living and way of being. So the one thing I'm fighting for, and you can choose to follow your own logic, but what we're fighting for at Paladino is to start the conversation around carbon with, we think you should go to 100% electric plant with 100% renewable energy, period, full stop. That's the first conversation we should have, because if we do that, we can eliminate combustion, which means our scope 1 emission problem is down to refrigerants. And that can be managed through due diligence with the property manager. We've got good controls on refrigerants, just in terms of the market. And it leaves us one effort to really get better at, and that's controlling emissions from embodied carbon, primarily in concrete, steel, and asphalt. It shrinks the problem down to something that's actually doable. And so scope 3 is our new frontier where we need to make progress. It's the dance period after the hammer. If you do this on most projects, and we've studied over, we've looked at over 50 projects since the beginning of the year with this idea around making the invisible visible. And renewable energy cuts the carbon footprint in half almost universally. It's the single biggest thing you can do. Now, as a designer, it's counterintuitive. We've spent decades trying to squeeze another 10% out of the building efficiency, and we've all worked really hard to get our lead energy points up, but we're not going fast enough. That exponential invisible problem of climate change and greenhouse gas emissions, it's too big. So my closing thoughts before we open it up to chat for any questions is, renewable energy is our hammer. If we want to take climate change action seriously, we've got to suppress that curve. We have to beat it with a hammer. And the way to do that is to buy renewable and make that shift as quickly as possible. The cost hurdle has become smaller and smaller. The end user interest in carbon action is higher than it's ever been. And once you decide to go all renewable, it changes the equation of what you study during design, and it changes what you think about as a property manager or an operations person. So we've got to make the shift, and that's our tact and position at our firm. So I'll go to the chat in a moment. But before we get into that, and just to make sure I don't forget, just like you're going to go home, you're going to put your mask on. If you're going to go outside and you're going to social distance, I want you to go home and I want you to check your utility and I want you to sign up for renewable energy today. You could do it today for your house. Just do it. It does not cost much money and you will begin bending that curve. So thank you very much. And we'll look for some chat from all the leaders that are on the phone.
So Tom, we've got a question from Patrice Martin. She wants to know how scalable is the prioritization graph that you showed? Big ground up versus TI.
Let's see. Sorry, which one? This one?
Hi, Tom. This is Patrice in Seattle.
Hi, Patrice. How are you? What's your question?
Actually, we're in the same. Well, not now, but we normally are in the same building in Seattle. Yeah, I thought this was really interesting because that scope 3 is so hard to get your head around, and I thought I appreciate the way you've broken this down into, the big rocks first. Don't worry about all those gravel and sand for the moment. And I was just curious if you've scaled this on different sizes, different types of projects. If you could comment on that.
Yeah, we have, Patrice. So you're right. This is this chart was for a large ground up new commercial office building. So those were the rocks. The big rocks was concrete, steel, and carpet. On a tenant improvement project, I suspect some of the FF&E might be the biggest carbon issues, and possibly your MEP and lighting, but those are really difficult to get EPDs on. We're finding those manufacturers haven't woken up. So I would say in your shoes, I would ask for it and see what you can get. Send the signal. And then on the TI, one of the secret, not secret, one of the invisible carbon footprints we found on some TIs is if you're doing any floor finishing, topping slabs, anything where you're spending a lot of energy to change something from one form to another and then covering it. So I would hunt for those. And then the last thing I'll say is all the charts and all the graphs and all the work that I've shown you today is pretty much multiplication and division. Like it's not rocket science. And so the things you're looking for are quantities and the factors. The factors are a little hard to find, but we're happy to share our factor sources because we've assembled, 3 or 4 key authors, EPA, Climate Leadership Foundation, and others. And they're the factors that we all have to hunt for. And then there's one new trick that every person will have to use is that climate is generally spoken about in System International units, metric tons, kilowatt hours, not MBTUs and pounds. So those are factors. So I hope that shed some light for you, Patrice.
Okay, we've got a question from Helen Kessler. Seems like this is a paradigm shift for most building owners. How do you get your clients to make the shift?
One way we've done that is a little bit with a graph like this. I think, are you all seeing the orange bars, one green box? Okay. So the size of scope 2, the biggest orange box, and the size of the darker box sitting on top of them, you can maybe see that they're both a little smaller than the one to the left. So those are because the engineering and architecture team studied how do I get my operational carbon, my EUI, from 40 to 34, which is the ILFI drop that you need to make, some ratio like that. And it turns out that in addition to taking 8 weeks to do the design work, the betterments to provide that reduction were on the order of 5% of the building cost, or in absolute dollars, 30 million, to get a 10% drop. And the delta in the energy cost per year was 100,000 to buy renewable. So in some ways, doing the quick math with everything I've shown you, so all those charts, almost every project in DC we work on has an energy simulation, which means every project could draw the blue and red and then gray and orange chart for carbon. And every project knows how to multiply EUI by electrical energy rate and get a total annual cost. That's just multiplication. And every project has a base budget, and every project can say 10% better, 10% add for the cost. Just do the quick math. You can do it on a napkin. It's like, I really think we should talk about renewable, because if we commit to renewable now, we can spend that 8 weeks on solving the next problem, which is scope 3. We don't need to solve scope 2 anymore. We can. I mean, it's good for professional services, but I can't tell you how many energy models we have built in the DC market with 20 energy conserving measures, and we are lucky if the client adopts 2 of them. So I've changed the conversation is one way, and change it through financial math is maybe the second suggestion. And the third one is you must be dogged and hold on to your hammer tightly as a professional, which is, I'm going to keep coming back to renewable because it makes sense for you and it makes sense for us, so that we can solve the next problem, which is body. That's your job as crew leaders. Don't take no for an answer.
Okay, we've got another question from Holly, wondering about cost implications for low carbon materials, low carbon concrete versus typical.
Good question. So back to the sort of hammer and the dance around embodied carbon and the cost is absolutely a real issue. What we found is that for concrete, for example, the issue is whether the signal's been sent to the concrete manufacturer to select materials from their supply chain, which would be cement. If they're the trade, it's where are they getting their rebar, and does the rebar manufacturer have environmental product declarations? And we've seen some sort of not wild ass guess, but maybe more wet finger in the air in terms of what's going to cost if we go with a low carbon concrete. Really, all we're asking people to do is manage their supply chain. Does that break down the problem? It's like, who am I buying cement from? Do they know how much energy is in their cement? Tell them when we're selecting them that one of the selection criteria will be how much embodied carbon is in your cement. Once you tell them it's part of the selection criteria, they will become quite diligent in figuring out what's in their cement and how they're going to prove to you that it's lower, and let the market do what it does best, which is compete. So I would say I'm sorry, was it Sarah? I can't remember.
Holly, it's Holly from
Holly. Oh, hi, Holly. Would be clear about what you want. So set a target or set a required submission, and state your intent to review it and evaluate them based on what you read. And you don't have to say how you will use the evaluation. Like, there's 10 points in the procurement for, providing the lowest carbon. Don't even tell them that. Just tell them it's part of the evaluation criteria, and here's what you require: EPDs and a carbon management plan for your supply chain. Just ask them for it. And you'll find out which contractors have intelligence and somebody on the ball who's broken down the problem and assigned purchasing and the super on the job and dispatch to make sure they get the right cement to the right batch plant to get it on site. And you've at least streamlined your own supply chain. So that's how I would tackle it.
Great. We've got a question from April Mills, wondering if you're seeing, are lenders evaluating the CO2 EUI number to increase rates? Do you know any insight on that?
Are lenders looking at CO2 to increase rates? I have not seen that particular phenomenon, but I have seen some of the REITs transacting properties in and out of their portfolio with some consideration of their EUI, or maybe another way to say it is their run rate on utility costs and maintenance. So, and then they're measuring the carbon footprint because they're all reporting through GRESB. So I haven't seen it direct to retail borrowers, but the financial institutions are taking a look at portfolio, real estate portfolios from a risk point of view. So you either have a risk of increased energy use because you don't have a handle on the performance of your buildings, or you have a risk associated with reputation because you're not reporting your carbon footprint accurately. And you may have a risk with your property managers and internal staff if you're making a carbon footprint statement in the market as a leader, but everyone knows you're really not doing it, which we've seen. And it's not because the company is being disingenuous or not telling the truth. It's that they don't have an internal organizational structure like that three-fingered tree I showed you, where it's just like divide the problem to 2 or 3 trusted leaders inside the company and let them run their work streams, and you'll get a much better result. So that's another risk. If your trusted leaders know it's not real, you risk employee flight. And right now, everyone is keen on not losing your best leaders.
Great. We've got one from Rob Stevenson. He's wondering about the occupants. In particular, how do we design to encourage less carbon burning from the tenants once we move in? Obvious ideas are EV charging, bike/shower facilities, less parking, and close to transit.
Great. How do we get more people to do that? Well, it's spot on in terms of whose behavior needs to change. We've done a little bit of work on a couple of campus scale buildings, one in particular in Seattle where the 5,000 employees, and you can imagine the size of the campus that would require, the carbon footprint was 3 times higher for commuting than it was for the building. So we had an entire team trying to drive the EUI of the building down, and yet the real culprit in the total carbon footprint was the commuting of the employees, particularly, as they expanded their workforce, because it was a growth mode for this new building. And so back to my hammer, if you commit to renewable and you offer the chargers and parking stations and change up your commuter pass incentive or whatever other benefit you've provided to folks to help them with their commuting. The more people that adopt the commuting program or EV charging or bike to work, you're leveraging that big part of the carbon pie that matters. And so the one thing the company can do is commit to renewable for charging, right? Because if you put in charging stations and you're buying the power from a dirty provider, you're really just swapping carbon for carbon. And so paying attention to how do I explain to my employees that the charging, and should you drive a vehicle, we're going to help you charge it with green power. And we know that an even more efficacious way to reduce commuting carbon is to put people on bikes, or even better, have them live nearby. So maybe we should locate our office near a transit station. So I think making the invisible visible to the employee, which is, here's your footprint with behavior A, and we are going to give you the possibility of behavior B, and it improves your footprint, and essentially is a more liberal solution for you. So make it irresistible, I guess, would be my suggestion. Thanks, Rob.
We've got another one. Where did it go? Okay. One of the major challenges for advancing renewable energy is regulatory. For on-site generation, utility companies' bottom line concerns also comes into play. What's your advice for negotiating these issues as a practitioner?
Good question. Well, if we go back to this chart, just understanding that the cost of PV is continuing to come down, and PV is your way to solve the scope 2 emission challenge. Then it's a question of, well, where does it matter where it is? Because if I buy it through my utility company by electing the rec power or green e-power, most providers now have an option, or you can buy third-party recs on the open market. It's a question of, is there enough room on your site to take down your whole scope 2 demand? And in urban locations, the answer is almost always no. So rather than get into a maybe contentious discussion with the utility, is to do the quick math and understand we need an array that's bigger than our site will provide. Let's find a provider who will do that for us and get to solving the other problems. Because there's utility green power available or through RECs in the entire United States. So you don't need to take on any regulatory issue. Now, if you're a authority with jurisdiction, for example, like maybe Arlington County, there are friends in Arlington County who are push. If they required you to put PV on top of your facility, then maybe that would create sort of a situation. So thinking through how what's the hammer I have? Not the one you wish you had. The hammer you have is, it's possible to buy power throughout the United States now. So I would suggest avoid that stuff. I'm so sorry, can you hear a leaf blower?
That's okay. We're at an hour.
While I listen to the question.
We're at an hour right now, and I believe we got to everybody's questions in here.
Thank you. There's the lull. Thank you all for your attendance. I'll let Lauren close before the leaf blower begins again.
Thanks, Tom. Kathy, correct me if I'm wrong, but this is a recorded webinar and we should have it to you, anybody who would like a copy of it within a week or so, if
Yes.
not sooner. And
Yeah.
if you have any questions, you can feel free to let myself or Kathy know, and we'll make sure to get you guys answers to anything that you're curious about.
Yes, thank you. Thank you, Tom, and thank you, Lauren, for putting this together. We really appreciate you giving us the benefit of your time and your expertise. Thanks, everybody who joined in today, and I hope that you enjoy the rest of your afternoon. We'll catch you on the next one.